Well, good evening. Thanks all of you for coming. This is quite the evening for us. I'm Bill Roach with the Environment Committee, along with Jack Carr and Andy Gordon from Let's Talk Science. We're supporting a very important person and a resident here, or two people, both Helen and Tom Spiro, who've worked over the last 5 years while we're living here at our Eisen House to write a book, which you will see in front of you. And tonight we're really pleased to hear from them about that book and about what it talks about. And the important thing, I believe, is that it's written for you and me, who are possibly not scientists, but it really introduces it at the environmental issues at a level I think that we can all relate to. So with that, I'd like to introduce Tom Spiro.
Am I on mute? Yes, you can hear me now. Okay, wonderful. Well, friends, thank you very much for coming tonight. And we appreciate the Environmental Committee and the Let's Talk Science Committee getting together to sponsor our talk. This is quite an evening for us. Many of you are probably familiar with the saga of our writing this book, since we've spread the word around quite a bit. So I'm Tom Spiro, and my co-conspirators are Helen Spiro, sitting over here, and Sasha Soldatova on the far side. Sasha is here with her husband Scott and her son Benji. Would you stand up wherever you are, just to introduce people to you? There they are, there and back. So Benji is a published author. At age 13, he has published a book with two mates on strategy and chess for young people. And very impressive, I must say. So let me tell you a little bit about how this book came to be. The origin is actually way back in 1970. I was a young faculty member on the chemistry faculty at Princeton University. And the year before, to my great surprise, I made tenure at Princeton. And it was a very tumultuous time, some of you may recall. The whole country was up in arms, as were all the college campuses. The Vietnam War protests especially inflamed many passions. And so my chairman called me into his office one day and said, "Now that you've made tenure, could you perhaps teach something that would be, relevant?" So I looked around and I said, "Well, actually, I'm kind of interested in the environment. I'd like to know more about the chemistry that goes on in the environment." So I launched a course, Chemistry of the Environment, which eventually led to a textbook, a copy of which is in the library, pretty thick text, a college text called Chemistry of the Environment. Well, when we got to Seattle, I took emeritus status at Princeton, and we moved to here, and I opened a lab at the University of Washington. And we made friends here, particularly with a very interesting man, Larry Smith, who unfortunately died this last year. And Larry really planted the seed for the book, because he saw my textbook on a coffee table Now, Larry is not a scientist, but he's a polymath and a speed reader. And he said, well, let me take a look at this. He took it home, read it one night, came back and said, you know, you've got a pretty sick story here, talking about the environmental narrative. Why don't you just strip out all the formulas and equations and put it out for the general public? Well, this sparked something in me and in Helen, and we took up the challenge. Now, it wasn't nearly as easy as just doing that. We had to reinvent the whole book, really, and I knew I had needed help because this had to be a book that non-scientists could relate to. So Helen took that on. I would research a topic, write it out as clearly as I could, hand the text to Helen, who would redline everything, saying, take this out, take this out. I'd have to rewrite. So that's why it took at least 5 years. And we were joined by Sasha, who came to Princeton actually as a postdoc my last year there and moved to Seattle with us, with her family, and trained herself in a number of useful things like computer graphics and web design, and she's a good illustrator. And she took a great interest in our project on the environment. So she joined up and has done all the figures for the book. They're wonderful figures, as I hope you'll have a chance to see. And also created a website for us. So we're very grateful for that. So let me get started on the story itself. I can find out how to operate this. Nick, I'm not having a success here. This is still on the laser pointer thing. Oh, I see. Okay, and then if I go back, I can. Yeah. All right. So for our introduction, we picked this photo, a very well-known photo from 1968. We landed on the moon, our astronauts, and they looked up and they saw this remarkable sight, this beautiful blue planet rising up over a barren lunar landscape in the black of space, and it filled them with awe. Here's a quote from astronaut Ron Guerin: "This stunning, fragile oasis, this island that has been given to us and that has protected all life from the harshness of space. We are all traveling together on the planet." And I think it really took many people in the same spirit. Now, it happened that this was 1968. The next year, 69, there were two well-publicized environmental disasters. One was that the Cuyahoga River, which ran through Cleveland, caught fire. There was so much oil pollution that it actually burned. Dramatic photographs were on everyone's TV. And at about the same time, there was an oil spill in Santa Barbara. One of the drilling rigs in the ocean sprang a leak, and oil came gushing up and smeared over the beaches of Santa Barbara, killing lots of wild birds. And again, these photographs made a big impression. And this really sparked the modern environmental movement. There had been environmentalists before, but now it really became a mass movement. 1970 saw the first Earth Day, millions of people sort of demonstrating on behalf of the Earth, and the government took notice. So it also led to the establishment of the Environmental Protection Agency under Richard Nixon, of all people, and the passing of important laws regulating air and water, Clean Air and Clean Water Acts. This led to a really substantial cleaning of our local environment. Water and air are much cleaner now in this country. You may not believe it, but it's true. Los Angeles, which invented smog, is now much cleaner than it was. The air is much better than it was in those days. But lots of other things happened in the next 50 years since then. Many things have gotten worse. And so it was time to revisit, we thought, all of the environmental issues that have come up. And so our book covers the ground. It does it fairly briefly, we hope clearly. In 215 pages, we cover a lot of ground. I'm going to walk you through this. Don't have much time, but we'll get through. There are 11 chapters. So the first one is our planet warming, or is it a hoax, as some would have you believe? So here's the data. We show a graph of the temperature from 1880 on to 2020. And you see, and this is the average temperature over that time, and you see it's pretty flat until about 1980, when it just takes right off, going through the ceiling. Now, some people scoffed and said, well, this is just natural variation. It's always been up and down. But it's not true. If you go back 1,000 years, it was pretty flat. 2,000 years, pretty flat. In ancient times, 10,000 years ago, we had an ice age. And there have been many ice ages in Earth's history. So cold and warm periods, but nothing as fast as this. This is an unprecedentedly rapid warming, and really can't be attributed to just natural variation. We know what's causing it. These are the greenhouse gases: carbon dioxide, methane, nitrous oxide. They trap heat in the atmosphere, just like a greenhouse does, and reflect it back. And so the temperature at the surface goes up. And we understand the physics is understood quite well. In fact, this can be now, with modern computers, very well modeled. So there's not much doubt about the source of the effect. And carbon dioxide is a product of burning carbon sources. Coal, oil, gas are the main cause, and methane and nitrous oxide are largely from agriculture. Modern agriculture uses a lot of fertilizer. Fertilizer releases N2O in the end, and methane. There are a whole lot more cattle and other farm animals than there used to be, and they belch, to put it politely, methane. So that's what it's all about. Now, if you ask, well, so what? So what is that a lot of things happen as a result. One is, of course, that people die from heat. Heat waves are, as we know, increasing. Their heat domes, which never used to be here, just because the temperature is going up. And fires. Wildfires increasing massively. Here's a map of the world showing in the red areas fires that were burning in 1 month of 2020 all over the world. This is a pattern that continues. Droughts, crop failures. Here's a cotton field in Texas in 2014. Sea level rise, the water expands when it warms. Ice caps melt, the sea level rises, inundating coasts. There are more intense storms and floods as a result. And finally, perhaps the most pernicious effect is that there are climate refugees, people who can't stay put because it's just too hot where they are, or the crops have failed, creating tremendous political problems. 2005 and 6, there were 1 million Syrian refugees that swamped Europe, creating great political instability and the rise of anti-immigrant far-right parties. The Syrian civil war had many causes, but one of them was a serious drought in 2010, which drove farmers off their farms and into already overcrowded cities, destabilizing them further. So, what's this all about? Well, one thing it's all about is energy. The reason that all that carbon dioxide is in the air is that we're getting heat, light, transportation, industry, all powered by burning our fossil fuels. Coal, gas, and oil are directly responsible for the carbon dioxide. And of course, the energy is essential for modern life. People's standard of living depends directly on how much energy they can use. And so that's the price of our energy increase. But there are renewable sources which are coming on very strongly, solar and wind especially. The sun shines and the wind blows as a result also. And this goes on all the time, massively. And we can capture that. Technology has improved to such an extent that it's now cheaper to build power plants using solar and wind energy than even coal, which is rapidly diving. So, and this is happening everywhere in the world. Those of you who had a chance to see Bill McKibben's talk at Town Hall, or its recording last night here, will know that the world is rapidly transitioning to solar and wind. And they're doing so because the Chinese are massively producing cheap solar panels and wind turbines and sending them all over the world, except here, of course, because we have a president whose motto is "Drill, baby, drill," and he's promoting fossil fuels as strongly as possible and trying to stall solar and wind. But that's not working very well. Even here in this country, these are becoming much more available. There are many obstacles to be overcome, but this is really happening. And whether it happens in time to really save us from further climate disasters is unclear, but it is happening, thankfully. Well, it's not just where we get our energy. By the way, nuclear energy is a whole other story. That many people are banking on that, although it's coming much more slowly than solar and wind. Using energy is just as important as producing it. If you save a calorie of energy, you're actually saving 2 more because it takes energy to produce energy. And so, for example, an aluminum can, if you recycle it, you save 95% of the energy that would have gone into mining the aluminum oxide and turning it into metal cans. Some other numbers are somewhat smaller, but still a lot of energy can be saved by recycling. And that's one of the things one can do. There are other things too. A lot of things can be made more efficient. And a very important theme is to electrify everything, because electric motors are much more efficient than other kinds of machines. And as we transition anyway to solar and wind, we'll be getting electricity directly as a power source. So if we convert to electric cars, electric heat pumps for heating and to replace furnaces, it's a big plus for the environment. Well, the plastic bottle reminds us of the topic, the sore topic of plastics. Very difficult matter to deal with. Plastics are an invention of the last century and a half. They come from largely from oil, the petrochemical industry, and they're extremely useful. They weren't invented for nothing. They're light, they're strong, they're durable, they save energy, save a lot of energy, as a matter of fact. But unfortunately, they get thrown out into the environment all over the world. And so you see scenes like this beach littered with plastics. Here's the production of plastics going up, and here's what results. And so how do we keep plastics out of the environment and also out of us? Because another theme is that unfortunately plastics degrade into smaller and smaller particles. They don't go away because these are not chewed up by the bacteria that are out there on the whole. When they get small enough, these particles can get into our bodies, and they have. We all have microplastics in us by now. And we don't know what they're doing, but they're probably not doing as much good. And so it's rather important to try and avoid a lot of contact with plastics in our food supply. So that's a theme that's being pursued, and it's a very knotty problem. We don't quite know how to deal with it, but people are advancing ideas about that. Well, what about air pollution? Pretty bad it's been. Here's an unusually clear day in Shanghai compared to the usual smoggy condition. You can see the difference. And here's another problem, that in much of the world, people still cook over open fires, breathing in the smoke. This is really bad for you. It's now well documented that air pollutants, mostly these tiny particles of carbon and other materials in the air, again, they get into our bodies, they impact lungs and heart. The lung disease and heart disease are increased quite dramatically. There's an estimated 7 million fatalities a year attributable to breathing these materials, almost all of which are there because of burning wood in this case, but also our coal, oil, and gas lead directly to air pollution. So that's another price to be put on coal, oil, and gas. There are ways to clean this up, the most efficient of which would be to stop using the stuff. You can't, by the way, do that very fast. A lot of people are going to depend on these fuels for some time to come. So it's a difficult problem which will yield slowly to our cleaner energy. Clean water is an even more intractable problem in many ways. There's a lot of water on Earth. Most of it's in the oceans, however, almost all of it, where it's unfit to drink because it's too salty. So we rely on fresh water. Fresh water is produced, again, by our friendly sun, which evaporates water from the oceans and rains it down over land, and we collect the runoff, much of which is now diverted to various purposes, human purposes, like agriculture. Crops require water, and the animals that are fed the crops require even more water because they use most of their water for their own purposes, leaving only a small amount for the meat that we eat. So a kilogram of beef requires no less than 16,000 liters of water. That's about 4,000 gallons, 1 kilogram. And so not eating meat not only preserves energy, but water, a lot of water. There are other uses of water. Industrial uses take up quite a bit of the water. The clothing industry uses an enormous amount of water because making, dyeing cloth and cleaning it is very water intensive. And the newest entry into this category are the data centers, which are going up and using a lot of water, especially in dry areas like the West. Finally, there are domestic uses of water, and that water had better be kept clean because waterborne diseases are very serious around the world. And although our water in the industrialized world is now pretty safe because it's been treated properly, it's not true of much of the world, which does not have access generally to sanitary water supplies. So this is a big problem. And then there are other toxic substances around, often in our air and water, and there's a great benefit to removing them. Here's an example. We used to have lead in gasoline to prevent knocking of the cylinders when they burn, which then was phased out. It was phased out mostly because of catalytic converters, which were mandated to clean the air. And it also had the salutary effect of getting lead out of the gasoline because the lead poisons the catalytic converter, and it poisons us because you can see that the average blood level fell dramatically when the lead was taken out of gas. Lead is a neurotoxin. It's especially harmful for children whose brains are developing, and so it's a good thing to avoid it. Another public source is drinking water, because if the drinking water is not carefully treated and goes through lead pipes or lead solder, it picks up lead. This happened in Flint, Michigan, as our CEO, Erica, knows very well, having been from there. And it took a lot of community action to get the lead out of Flint water. There's a big story there, which I won't have time to go into. And then we go on to we can just get this moving properly. I'm having trouble, Nick. There we go. Okay, biodiversity. Now, I know very little about biodiversity, so I consulted the expert, who lives right here, Gordon Oriens. Unfortunately, he couldn't be with us tonight because he's not feeling well, but he was very helpful to us in pointing to lots of material on biodiversity. It's a rich subject because ecosystems are rich with diverse plant and animal species, and the richer the better. Here's an example of biodiversity in action. The wolves of Yellowstone is a nice story. Wolves were hunted out of North America back in the early 20th century, but were reintroduced slowly in the Northwest into Yellowstone and surrounding areas, and had a very salutary effect on the ecosystem because the elk had multiplied and denuded the stream banks, and so the rivers were polluted until the wolves chased them out. And it had a salutary effect almost immediately on the quality of water as a result of beavers coming back and all kinds of species that had been had left. We're destroying biodiversity in much of the world, especially in tropical forests by logging. You'll see great loss of biodiversity. And in the oceans too, overfishing is a big problem, and is the pollution of coastal areas. So replanting mangroves, producing more coral if possible, which protects shorelines, is a really good thing. Nick, I'm just not having much luck with this. I don't know why. What have I done now? Oh, the leg. Got to tell my right from my left here. So food is a big topic. Agriculture, we've appropriated much of the planet for our agriculture, with some really serious effects, the loss of habitat, pollution, because modern agriculture using chemical fertilizer and pesticides leaves a lot of species in the dust. And so there's a big movement afoot to try and improve agriculture through various techniques, which I won't go into here, but are covered briefly in the book. And there are new directions, as you can see illustrated here. Urban areas have a lot of vacant land, it turns out, which can be used to grow food. Community food gardens are increasingly important to people in urban areas. And here's an example of the marriage of agriculture and technology, because it turns out that solar panels provide shade so that the earth underneath doesn't dry out as much, and crops benefit from this. So agrivoltaics, kind of a tongue twister, is a coming thing here in this country and the rest of the world as well. So there's hope for new agriculture. Oops. And finally, we come to sustainability. It's on everybody's lips. Everyone wants to be sustainable these days. Almost all companies, up until very recently, had sustainability initiatives. What does it mean, sustainability? It's very hard to pin down, actually. Essentially, what will we leave to the future is the question. And measuring sustainability is very difficult. It's easier to see unsustainability. A lot of what we do is unsustainable. And here's an idea that people are working on to produce a circular economy to replace our current linear economy. So at the moment we extract stuff from the earth, food or minerals, and produce products and then throw them away when we're done. Well, you can't, I mean, throwing away just leaves them around. So what we need instead, if we're going to sustain this industrial economy of ours, is a circular economy where you don't throw things away. You produce them and then you use them as long as possible, and then you recycle them. And a lot of people are working on ideas to do that better, some examples of which are in the book. And then we have to think about future generations if we're going to be sustainable. One issue is to restore much of what we've lost. And there are many examples, one of which is right here in Seattle, because the Thornton Creek, which drains much of North Seattle, was paved over and channelized for development early on, and it's now been rehabilitated. It's been daylighted, so you can see the creek again, and a proper bed has been restored so that you can grow its native organisms. The river slows down. It doesn't flood as much anymore. And magically, the salmon have returned. This is a big issue for the Northwest, the restoration of salmon habitat. So that's a success story here in Seattle. Looking at the long term, we can cite Native Americans who believe that wise action now should meet the needs of 7 generations into the future. This is the origin of the 7 generations label. And they took their inspiration from the Iroquois Confederacy, which was founded in 1142, long before Europeans got here. And its great law of peace, which incorporated ideas like 7 generations. And the Confederacy actually inspired Benjamin Franklin and other framers of the U.S. Constitution. Wales is taking the lead on this. The country of Wales has a Well-Being of Future Generations Act, so all public bodies in Wales have to write out and specify what they're doing for future generations. There's a commission that oversees this. It's quite a remarkable invention, and it's being looked at by the rest of the world. So that's the note that we leave the book and you on. And we thank you very much for coming and listening, and we'll be happy to answer any questions. Books will be on sale and for signing afterwards.
Yes, I was surprised by the Wales bill generation. Is that kind of legislature likely to spread beyond? I don't know what the impact of Wales is because it's only part of the UK.
Well, that's a very good question. It is being looked at by lots of places. I'm not aware of others that have implemented anything like that yet, but I think it points to a direction for the future. Yes, Rudy.
I was interested last night and this night's presentation both, where there is very little said about batteries or how solar energy and wind energy are stored. And then I didn't see any wires going out from the solar field, and I'm just wondering how this all works. I understand about the visible materials, but how does it all?
That's Judy raises a very important question. Two questions actually. One is what you do when the wind dies and the sun goes away. You need that energy all the time. So energy storage is a really big topic. It's been cited as a negative by many people, but storage is coming along. Battery technology is improving rapidly. China is taking the lead. They're producing longer-lived, cheaper batteries than ever. It does require mining of rare minerals, as you know, and that's an issue, although it's blown out of proportion in many cases. But at the moment, the Chinese have a lock on, on the rare earths that are required by many of these devices. And also the issue of transmission lines. We know that that's a really big problem because often the energy is produced not where it's needed. You've got to get it from the sunnier, windier areas to the cities on the coast mainly. And so transmission lines is a very big area of concern, and building them out fast enough is a big barrier.
The new push for AI and all of the energy that uses is going to have a profound impact because we can't produce energy enough for all of the, I don't know what they call them over in eastern Washington, all the little plants that produce all that energy and the heat, and it takes a lot of energy and water.
Right, it's a big issue. People are discussing it extensively. Huge amounts of water and energy are required by artificial intelligence, which is growing by leaps and bounds, as you know. Now, it shouldn't be taken out of proportion. It's about 2% of the energy or water at the moment. Of course, it could grow much larger, but it might not. It's another side of this, which is AI can also be used to help make things more efficient, both for energy and for water, and there are a lot of people working on that. So it's not absolutely clear how it's all going to work out. And in any case, is AI a bubble? We don't know. So it's something to watch for sure, but it's not currently a serious problem.
We hear over and over how China has a monopoly on X, Y, or Z, this rare earth or that rare stuff. But what are the rest of the nations doing about it other than just buying it from the Chinese?
Well, at the moment, nothing. They're just buying it from the Chinese. There are alternatives, but they're more expensive at the moment by quite a bit. So the Chinese have managed to undercut just about everybody else, and that'll continue for some time until the other technologies start to take hold. David?
So I actually asked Chat GPT-5 that question the other day. Now, can you trust the AI with the question about AI, about the projection? So to what extent would the build out expected in AI in the United States over the next 10 years, what amount of electricity would it require from generation? And it went through a whole long set of calculations, of course, in which I was, wasting electricity, and eventually came to the conclusion that it would be somewhere between 3% and 21%.
That's a big range, big range. Thank you, AI. Question here, Elizabeth.
Hi. Your book is wonderful. I've got it from Amazon and enjoyed reading it a lot. One of the things I was looking for, you do address some of the social political issues, but what I'm really interested in is people's resistance to change.
Yes.
and how we can deal with the people that make their living on coal and oil production and corporations that benefit from that and so on. So I'm thinking about the effort needing to be made to help people adapt to the changes we need to make in order to preserve the environment. I'm relating to the coal miners and so on because I just recently had to move from the West Wing, and I was very disturbed by that, and so my sympathy is for, how difficult it is for people to make these changes. Here, fortunately, here at Horizon House, the Horizon House staff were very helpful in making it as easeful as possible. So, but politically, socially, we need to develop policies that help people make these transitions.
Very important point, I think. We've really glossed that over in our recent history, because the loss of all those jobs has been accompanied by the growth of other jobs, but they're not in the same places. They're elsewhere. And to expect people to pick up and move is really asking a lot. So these communities really need help. We can see that politically as well. The political consequences have been profound. And I think that hasn't been thought through well enough. Now there are measures. I mean, even alternative energy comes to the rescue in some cases, where you can convert these strip mines to productive solar and wind energy installations, but it's a long haul, and it hasn't been done systematically yet.
Okay. Well, I guess we need to bracket Trump as a disaster. We have to bracket Trump as a disaster. What I want to really address is plastic. And one of the things that really bugs me is that we have all this organic food, wholesome food wrapped in plastic. And how many people are addressing this problem? The industry needs to stop making plastic. So is there any solution to that?
Well, yes, there is. It's not the plastics. Plastic wrap of food can actually be a very good thing because it controls access to oxygen and keeps, the food is preserved. It saves a lot of food waste, as a matter of fact. But what you need to do is get it away from that plastic as soon as possible and keep it away. And that just hasn't been part of the culture or the industry, for that matter. There's a lot of moves now towards what's called extended producer responsibility, so that the people producing these products take responsibility for what comes next. And that just hasn't been implemented enough yet.
Well, it's possible. Oh, one more.
We have a good friend, classmate, and so forth, who was a hospital administrator, Deaconess Hospital in St. Louis. He retired from that somewhat early and bought a farm, about 200 acres, and almost immediately used the pasture field with a big solar installation. He's been selling electricity to the electric company for probably 50 years. And some people have got into this early, and why others I don't know, but it's always seemed like a wonderful idea.
Thank you.
Thank you, Tom. That was great. I'm really interested in biodiversity. And it seems like when I get a lot of requests in the mail for charitable donations, all of the attention, I think because it pulls at our heartstrings, is for the big animals, the elephants and the whales. Can you address the issue of at the level of microbes and the least exciting animals and plants and bugs, shall we say? Is there a reasonable expectation that we'll be able to preserve these kinds of underpinnings for the world, essentially, through conservation efforts?
Well, I think that's a very important question. There's something called the insect apocalypse currently. It's quite noticeable if you drive through the Midwest that your windows are no longer smeared with bugs nearly to the extent that they were before. And it's been well documented that the insect populations have dropped dramatically. Now, it's not entirely clear what's responsible, but there's no doubt that A, loss of habitat, and B, insecticides are a serious contributor to that. So there are moves to regulate these. Europe is much further along with that, but it's going to take something of that sort to get away from harmful practices, because these insects are really at the base of so much of our life, as you say. Pollinator, famously, bees are dying all over the world, and many other insects as well.
About plastics, I understand there have been some microbes that have evolved to consume plastics. What's the latest on that, and how much hope is there in that as a solution?
Oh, I was looking for you, Connie. Thank you. Well, that's a very interesting point. There are microbes have been found that chew up plastics, especially in dumps that have plastics. They evolved to consume the plastic. So there is hope that they might do that to a greater extent. The big problem is that these bugs only eat what's in front of them, and they require a fairly concentrated food supply. So when you have a plastic dump, you get bugs that eat the plastics, but dispersed through the environment, it's a much harder job. So I don't think it's likely that that's going to happen very soon. I don't think we can rely on those organisms.
So I have a solution for all of the excess packaging that happens. Like you go to Costco and you want to buy a lipstick, and it comes in a 15-inch plastic container so you don't steal it. And so I think what we should all do is take box cutters to the stores, cut out the excess of plastic and leave it for the store to deal with. And after a while, they'll find that it's cheaper to let people occasionally steal a tube of lipstick than to do all that. And but that, our creativity. I was so moved yesterday by what our speaker on the movie was talking about, like pollinators under. You talked about having vegetables growing under, or plants growing underneath the
Solar
field.
panels, yes.
And he said pollinators are particularly, they can't stand the intense heat, but they can do fine underneath those voltaic
Very
panels.
good. Yeah.
So,
Well, it's a great idea. We'll have to put it in the next edition. Take your box cutter to Costco.
any store. It's not. That's particularly bad in the big spot, but
Right.
there's excessive packaging everywhere.
You bet. Thank you.
Any other questions? Yes, I'm reminded that Tom will sign the books up here for those who are interested in buying them. But another point here is Ginny Stimson, who has an idea. Ginny?
I've had the advantage of seeing this book for a few months now, and I think it would be wonderful for those of you who buy the book that we have a book time to have kind of like a book club to talk about the chapters, like maybe reading 3 chapters at a time and coming together. And Tom is willing to be available. So what I have up here is a sheet of paper where you could put down your name and room number. And what I would do is send out something to find out what we want to know, how many people might be interested in such a book discussion. And I would lead it in a particular way. So I'm going to describe that briefly. And it's called the Last Word Protocol. So I'd ask you as you read, say 3 chapters at a time, to identify a place in the text that was really important for you to read because it helped you to understand something better by the way it's described, or something that got you to think about something you hadn't considered before, or something that you want to learn more about from Tom. So that you'd mark some 3 specific places in the text and you'd come and share that in your group. It's really helpful if you're reading to have people actually refer to the text as opposed to talk off the top of their heads. So I would ask you to choose 3 places, maybe with a Post-it note or a paper, and say, these are the 3 things that are most important. We'd have some small groups that would talk, and Tom would circulate and listen to the discussion. This would actually serve other purposes for Tom and Helen, and that is that we're interested in having this book used by students in school. Right now, there's a class called AP Environmental Studies, where the kids we've tested out the book a bit in some classrooms, and to hear what your issues are and your questions could help inform the teachers who might use this book. So, or could give you some ideas for revising the book perhaps. So up here I have 3 sheets of paper and 3 pens. And if you could put down your name and your room number, if you're interested in discussing the book with other people, I'll organize a time when we can get together. Like I said, I was thinking about every 2 weeks if we took 3 chapters. And I know when I was reading it, I was so happy to listen to the discussion last night and thinking, yay, I actually understand that issue better because I've read this book already than I would have understood it before. So it's an accessible book. It has data. One of the things the teachers were so excited about that I've looked at it is it has very specific recent data that support the claims that are made in the book. So it's accessible, but I think we would benefit from talking together about the book as well. So if you're interested in being part of such a discussion, please come up and sign up to do that. Thank you.
You can tell that Ginny's a talented teacher, and we're very grateful to her for putting us in touch with the teaching community. We had really good discussions, and in fact, one of them is mentioned by Ginny. Jen Fox is her name, actually used one of our chapters in her class and was very pleased with the outcome. So that's a direction which we would like the book to go in the future. Incidentally, the website which we have, which you can access with the QR code that Sasha developed, or with the website address that we can give you, we'll have updates. So I'll have, perhaps every week or 2, an update on some topic that's had a new development, and that's also something we can work on.
Like the solar hanging off the balcony.
Yeah, the most recent update has to do with the fact that in much of Europe now, people routinely buy solar panels to hang on their balconies and plug into the wall to reduce their electric bills. It's coming to this country slowly, but the state of Utah, of all places, has made a law that allows this to be done more easily.
We'll work on that here. With that, we want to thank you very much for coming. There are a number of steps you can take in terms of Ginny's idea, as well as the book itself. And I know Tom is available for further conversation. So thank you very much for coming tonight.
Thank you.